Have you ever wondered how sensitive electronic components are shielded from electrical surges, or how a circuit can maintain a perfectly steady voltage despite fluctuations in the power supply? It is a common challenge in electronics design, where stability and protection are paramount for reliable operation. A current-limiting resistor is absolutely essential when using a Zener diode in most voltage regulation applications. Without this series resistor, the Zener diode would be instantly destroyed by excessive current, failing to perform its crucial function of maintaining a stable output voltage. The fundamental reason lies in the Zener diode's characteristic behavior. A Zener diode is specifically designed to operate in reverse breakdown, a region where it maintains a relatively constant voltage across its terminals, known as the Zener voltage. However, to achieve and sustain this stable voltage, a specific amount of current must flow through the diode. Without the series resistor to drop the excess supply voltage, the full potential difference across the Zener would drive an extremely large current through it, far exceeding its maximum power dissipation rating. This excessive current leads to rapid overheating and thermal runaway, ultimately destroying the diode. The resistor limits this current, ensuring the Zener operates safely within its specified power limits, dissipating the excess energy as heat. To properly size this resistor, you typically consider the input voltage range, the desired Zener voltage, and the maximum and minimum current the Zener diode needs for stable operation. First, determine the maximum source voltage and the minimum load current. Then, use Ohm's law, subtracting the Zener voltage from the source voltage, and dividing by the desired Zener current plus the maximum load current to find the appropriate resistance value. Always select a standard resistor value slightly higher than your calculated minimum, and ensure its power rating can safely handle the anticipated power dissipation. Beyond simple protection, this current-limiting resistor also helps manage the dynamic impedance of the Zener diode. Zener diodes have a small but significant internal resistance, often called Zener impedance, especially at lower currents. To ensure the diode remains in its breakdown region and provides optimal voltage regulation, a minimum Zener current is required. The series resistor helps establish and maintain this necessary current flow, ensuring the Zener diode can effectively clamp the voltage to its specified level while accommodating variations in the input voltage or load conditions. It actively controls the operating point of the diode. In essence, the current-limiting resistor acts as the Zener diode's vital partner, enabling it to fulfill its role as a voltage regulator without self-destruction. By carefully selecting its value, you not only protect the diode from thermal overload but also guarantee consistent and stable voltage regulation for the rest of your circuit, leading to overall improved reliability and performance.